Hi, welcome to Detection Testing with CICD and AI, the workshop for DEATHcon 2024. My name is Dennis Chow, and I'll lead you through this workshop, and then we'll learn a little bit more about the CICD process, along with detection as code, and how to use testing and integration with that for your detection engineering efforts. A little bit about me. I'm currently an independent consultant with EY. And so by function, I'm a service delivery manager, and I'm as a subcontractor for many different roles. In the past, I've worked at Amazon Web Services as a consultant. I've also been a consultant with RSA Security, directors at KPMG, and I'm a former Air Force person. Um, Throughout my career, I've learned a lot about different detection engineering and Office of Security related processes. And I want to share a little bit about this with you as well. Some of my public contributions include my Medium, YouTube, and GitHub. So if you want to take a look at any of this outside of the context of this workshop or anything else I produce, check me out at DW Chow and some of my other aliases there. You can also connect with me on LinkedIn using the alias DW Chow. Part of this workshop is based on my recent book that just dropped, Automating Security Detection Engineering. The QR code list that you see here goes directly to our free labs. So if you don't have cash for the book or that's something you can't support right now, that's okay. Go ahead and take a look at the labs, and you can actually find a lot of our sample code here from this workshop. We're going to do a little bit of a different portion of these of the book within the workshop with a slight twist. So stay tuned. Today's agenda includes CICD components, so understanding the technical foundations behind how runners work and operate. Next, we'll use detection strategies with detection engineering. So testing strategies include unit versus integration and end-to-end based testing, including our synthetic AI-driven related use cases. Lab demonstrations will be a four-part mini lab, and I'll walk you through the solutions accordingly. Last, we'll use a summary and tips. So how do you get more mature in your program and processes related to detection engineering and detection as code as a program? So CI/CD components, for those of you that are not in the know about this, we can usually divide it based on 2 to 3 different main groups and specific files. So we're going to use modulated stages. We want to use locally developed repos, and we want to push to a remote repo. So right, and you're using GitHub Actions, GitHub repos. They all kind of integrate in the same way. We use event triggers based on one more action. So if we're pushing things to commit and saving to a remote repo, that triggers an event to start the pipeline process. Any action that you take is considered a runner job. So when you look at CI/CD pipelines outside of GitHub or any other vendor-based solutions, we call them runners in general. They facilitate testing, delivery, or deployment depending on the job requirements and the stages that you build in there. So looking to our left here that we have build spec, detections, and our test cases. That is one group that you'll be building in as a detection engineer most of the time. And then with that said, the build spec is something that changes. So consider it a scratch pad for variables. So as you create detections, you create test cases, you have to like label them and give them file names and test case path names in most cases. And the second part of that is detection. So what you create on a day-to-day basis. So usually you're doing a local development of your regular expression signature or some other patterns, and you need to create that detection to get uploaded to the GitHub repo. Last is that you'll have your test cases, and that's probably the hardest challenge of this. And that's why we have this workshop. We'll have to learn how to create test cases. How do you create a consistent test case that gets automated into a pipeline? And for those of you that don't do detection as code today, that's okay. We'll be doing some deployments, but we're mostly going to be focused on the unit and the integration testing here. The runner scripts are part of a grouping. So think of it as things like YAML or any kind of structured format that gives the direction to the compute. All pipeline is at the end of the day is a remote compute function that you still have to make programs for and mini scripts and tie it all together to make an automated workflow. The only difference is that someone else is hosting it and is event driven as opposed to cron job driven. Our third grouping is test scripts. So these are what we'll be focused on building today for the most part, although we need to incorporate numbers 1 and 2, and we'll have those samples in our labs today. Last but not least is deployment scripts and post-deployment test scripts as well. So depending on your hooks and the different stages of your pipeline, if you're doing delivery as opposed to deployment, You can actually have two pipelines or more. You can even just have one single pipeline, depending on your deployment and lifecycle strategy. Always check with your enterprise development teams and enterprise architecture teams for whatever your security requirements may be. But in general, this is what we're going to be building today. So, what makes the CI/CD components relate to the build spec and detections? As we just talked about, the build spec is machine readable, right? So you want to think about structured format, CSV files, JSON files, YAMLs. And remember, we're focused on making a variable scratch pad. So to my far right down here, at the bottom of our screen, we're looking at, in particular, the build spec example that I put here and potentially YAML. For purposes of our lab and keeping it simple, I like to use CSV files, but remember that every detection engineering requirement is different. As we produce more items, we also have detections. So a number of detections in X tool syntax. So domain specific languages. So if you think of Splunk as a SIEM, that's SPL. If you're looking at Suricata or Snort, right, they have Snort style signatures and so on and so on. So as long as you have a structured capability. Now you can actually create a framework on top of that. And there's other discussions and projects that go in tandem with that. But our items that we're going to create detections for and test cases for, want to use signatures and other things that have tooling that can actually easily accomplish this natively in CI/CD pipeline land. Last but not least is our test cases that we're creating detectable payload conditions. So think of it as a way of you testing it in an automated format, you labeling that test, and that becomes part of your pipeline. And the reason why we have test cases, even though you might actually deploy and test these locally, is largely because you actually want to make sure that any revisions that you do in the future, including change control, version control, adjustments, and tuning, those test cases still apply. And so when you're applying the same test case, you can actually catch yourself with human errors or any other detection oversight based on those changes there with this pipeline. To your right, we're going to utilize GitHub action flows. And so the structured repo folder kind of looks like this. In general, you might see a build spec. So if you've been wondering about repos that have build specs, that's what this file is for. We'll have a folder for tests and detections to keep ourselves organized, and then we can add multiple detections and tests. The build spec file points to these detections and tests together, depending on your test path and needs. Last is our actual runner itself. The runner YAML file is simply an orchestration thing that actually activates multiple scripts that you don't see here, focused on activating and utilizing tests and getting the return feedback from those tests based on those results. Last part of our CI/CD components foundations here is that I wanted to show you what a runner YAML looks like inside GitHub. So I talked about the name of it, but also the event. So every time we do a push to a particular branch, we're going to also specify the actual prefix of the folders as well as suffixes of the type of files that you want to make sure. Now, it doesn't use file magic. You should use extensions based on what the file name is. You can also do so on pull requests on the same main branch. So if you do trunking, you can certainly do this on this action runner on every single commit workflow. Last but not least, over here in the event triggers is workflow dispatch. This is specific to GitHub. So if you want to do a manual trigger inside the GUI, utilize this as part of your first set of conditions. How do you get secrets? And if you're using especially cloud to cloud solutions like GitHub Actions to something like a cloud-based EDR like CrowdStrike, you actually you need to use environment variables. So we'll be utilizing some of this in our upcoming labs for integration testing. But I want you just to focus on key aspects of it. Just like inside Bash or any kind of shell, we actually call environment variables based on an alias and the payload information. The secrets management inside GitHub is actually built in. You can actually do additional call outs and perhaps populate the same variable using a third-party secrets manager, but we won't be doing that in this case. In our labs, we'll be using the built-in GitHub action secrets. Secrets management allows you to actually grab the plain text version of your secret, even though it's stored and encrypted inside an escrow somewhere else, usually via API call or a different service. Next, we have the additional steps that we utilize in our pipeline, and followed by the running the actual in this case Python script to actually run the test detections in this case. So you can actually have it run just like you would do any kind of bash shell script, except that we're a little bit more structured and we're utilizing this in a GitHub action flow. one thing I wanted to keep in mind is that inside the runtime script, you're actually calling test scripts, deployment scripts, and any post-deployment test scripts. And that's how you can visualize what we're going to be doing today. Remember that all GitHub Actions YAML file, which is this one, calls test scripts and deployment scripts, right? So that's just an orchestrator, a way of organizing our job for our pipeline. So let's move on to testing strategies. So what is a unit test? What is a test in general? Well, in general, any test is a process that completes that says, hey, I matched something based on what my conditions that I passed and failed at with. We use process status codes in Linux. Bash in particular has 0 through 255. You might see these in different scripts over time and how you utilize them in the administration portion. In general, the exit code of 0 always means success from a Bash or general Linux perspective. Exit codes of non-zero, 1, 2, and so forth can also mean different things, and these are the defaults kind of known in Bash. And Xcode 1 is generally a catch-all. So as you do additional debugging, you can actually build very complex test scripts that do access beyond just one. But in general, for our lab purposes, we want to actually just focus on passing a test and failing a test and creating those conditions accordingly. In this script, I have a test case that says, check out a Splunk search, run the query of the search, and if you get results back based on that query, such as an SPL query, and you get the actual log results back is greater than 0, pass the test. Anything else goes to a failure, and then we restart and clean up the, in this case, an integration level testing all over again. In addition, we have additional items to make sure that we have a cleanup in case the script fails or has another error condition, regardless of the test case information together. So remember, exit status 0 means a pass. Anything non-zero is usually a fail. In our testing strategies, let's talk about unit testing. Unit testing inside a developer terminology is usually based on a function or a very subset of code. In our world in detection engineering, we actually create everything as code, right? And we create very specific signatures and detections each time. So most of our tests are going to be unit tests by nature. So think of it as logical testing per function, and we aim to simulate, not emulate, the expected condition. The difference between that is simulation allows you to create the detections completely in the pipeline, and you want to try to synthesize what it might do before it gets to a production deployment. This is better utilized for upstream detections of the SIEM. So think of EDR, your IDS, WAF detections, anything that feeds the SIEM is considered upstream. It's relatively fast and cheap based on the amount of runtime. So in general, unit testing should be something that you can have an ephemeral test on. So this is actually great for things like IDS signatures and EDRs, especially when you don't need a full-blown deployment, um, depending on your solution and your commercialization of those tools. You can also use them in tandem with linting. So linting is not the same as unit security testing or unit testing in general. Linting is based on syntax and best practices formats for easier read or potential parsing and bad characters. So think of this in a pentest world as removing extra characters that might cause an encoding issue with your payload. Here we can see the unit test in this case, and here's an example that we'll actually utilize in part by the lab. I use a simple bash shell script to actually make sure that I say, here are the rules. And this is just basically the same as a build script. So this is the rule, this is the username if I wanted to look at parameters. Here's the pcaps, and then iterate inside this folder all the rules and all the rule names and ensure that the pcap makes a rule fire based on them. If I get a response back, then the rule has matched the pcap. If not, fail accordingly. In addition to testing strategies, a lot of our time in detection engineering, beyond unit testing, is integration testing. Now, I want us to think about this for a second. Integration testing inside developer terms is usually the fact that APIs speak to other APIs. But the main thing about API to API is that you're testing the traffic usually and transfer that traffic. It's a little bit different for us in detection engineering. And the reason why is that we're trying to emulate as opposed to simulate. Emulating being that we're trying to get to as close to staging and QA or production as much as possible. And we're going to generally have um, permanent infrastructure. When I say permanent, I mean long living infrastructure that's you don't want to continuously try to set up inside an ephemeral runner each time. So we're actually creating live fire detections utilizing the integration testing type. The return on investment is usually a medium cost and speed depending on how mature your organization is. So in general, if you're utilizing a limited amount of CI ephemeral minutes, you generally want to limit your test integrations or host an external runner yourself. In this case, I'm utilizing a snippet of a integration test using Splunk again. Again, you've seen this earlier before too. The only difference is that we're making sure we're live firing it, and we're likely running this on infrastructure that we host externally. There is optimization issues when you think about maintenance and overhead. So as you're looking at your testing strategies in a program perspective, think about this. Do you really need to have integration testing? And the answer is yes, only if you're looking for ensuring that your environment um, would closely match and mimic the production level environment that you're trying to test against. This is suggested for more mature organizations in practice. Our last of our testing strategies includes somewhere in between. Synthetic unit testing is something I came up with in general. With the advent of generative AI and LLMs and APIs that can access them, we can utilize synthetic level testing to kind of be a bridge between unit level testing and integration testing. This is especially good when you're utilizing tests that or detections or use cases that have a difficult time recreating payload in many different environments. You can think of synthetic AI-based testing as kind of a peer review, but only a little bit more focused and tuned based. We would like to utilize a tuned bot or tuned model in general to become a domain subject matter expert and then give you confidence ratings. So one opinion, this is an opinionated way of testing unit via synthetic AI, is utilizing a pass-fail based on the qualitative conditions, such as a high, medium, and low perspective. Anything that's not a high or in terms of a confidence level can possibly be failed depending on the type of item. So in this case, I have a warn, I have a hard failure here, and I have a pass because the confidence level is high here. This is probably good for teams that are lower on the maturity scale and trying to move into the next level. And so if you have a very short staff of perhaps one or two detection engineers, you don't have the time to PR every single detection, but you want that extra pair of eyes after a traditionally a logical unit test, but you don't need to have infrastructure overhead for integration testing. This is a great supplement, and it also gives you some additional risk items in here to consider. In addition, you can utilize multiple AIs, not just a single AI, to have kind of have a voting system if you would like that as well. So, to summarize our testing strategies, a unit test is each use case with real payload, testing it inside the pipeline. In the developer world, you're utilizing a subset of code such as a function or a particular service. The integration test for us is usually like testing payload live fire in a production-like system, emulating as opposed to simulating. Integration tests inside the developer's world is usually an API talking between each other or different services, focusing to ensure that the traffic is actually received and responded to accordingly. In our world, synthetic tests are related to AI and performing a basic level analysis on it, utilizing either log payload or any other payload that you can actually give the AI and giving a confidence level without actually exploding the test itself. Synthetic tests inside developers are typically application performance-based baselining for their user activities and looking for UI UX conditions they otherwise would have not caught. Finally, the thing that we also did not cover inside this particular workshop, but I want to make sure that we call it out anyways, is the idea of end-to-end testing. In our world, that might be a combination of all of these up here, or actually utilizing coupling of multiple TTPs in complete attack scenarios. So think of BAS tooling such as Caldera, Safe Breach, and anything else that you may use. But consider the fact that end-to-end testing is the most expensive portion of all these and combines usually all three of these together in the same pipeline. End-to-end tests inside developers ensure code works for all of this, including edge cases and sometimes including dynamic fuzzing. So keep that in mind as we go forward. All right, now it's time for the lab demos. We're going to be building OSSEC with local unit testing to get our feet wet. Next, we'll use Suricata unit testing inside a pipeline. Then we'll build synthetic unit testing in the same, well, a different pipeline with GitHub using SPL as our example for Splunk. Last, we'll wrap up with ABIS Event Bridge integration level testing. So you actually get to do a deployment um, and do test cases of deployment in a live fire-like environment. Give me one moment while I get the labs prepared, and I'll see you there. Okay, welcome back. I've got my lab files open here. In this case, I've called them DEATHcon workshop files. However, yours may be called something a little bit different. In general, our labs are focused on items 1 through 4. There's a presentation as well as a student lab guide here. The student lab guide can be open inside typical Word, and you can follow along with me, or you do so asynchronously on your own time. I will be following the lab guide that was created, but you can actually do the labs not in sequential order. You can do them as time permits, independently of each other, however you may wish. So let's go into the AWS. I'm going to start off with the setup of the OSSEC items. So I'm going to start off with logging into my AWS account that you hopefully have as well as part of your requirements. Let's go ahead and create this a little larger so we can actually let you see it a little clearly. Alrighty. And then so we have, in this case, a single AWS account that you are hopefully clean on, and I alone have AWS administrative access here. If you have a root account, you should use an IAM user that has administrative privileges just for the sake of safety, but if not, that's okay. US East 1 is what we're going to be operating out of for all of our labs today. And I'm going to just use Cloud Shell in this case. We'll start off Cloud Shell right here. In this case, we're starting off with the OSSEC run, and you can actually utilize any kind of Fedora or CentOS-based Linux. You can also use Ubuntu, but our steps may differ slightly. So what we're going to be doing is installing OSSEC. And for those of you that are unfamiliar with that, that is an older age HID system that has transformed itself over the years. In the lab guide, I'm pasting in um, our Atomic Corp saying yes here to make sure that we add that repo to the Yum system. And if you need some help, there is the OSSEC guides for installing on AWS Linux 2 here. So simple Google will help you out here, but I've consolidated these steps for us here. All right. So for now, we're going to go ahead and ensure that we are setting up OSSEC according to what we want. And I've made sure I've added that here. Let's go ahead and do a sudo yum install OSSEC. You want the server, not the client. So we're going to be installing that in a second. I'm going to say yes because the default is no here. Okay, here. I'm going to just go ahead and make my screen a little bit easier for you guys to see without my head on it. Okay. So now that we have that installed, we're going to go return to our lab files. I'm going to go into the DEATHcon 01 right here. I'm going to go ahead and grab the OSSEC lab files, in particular these three. I want to upload these three to our home directory inside Cloud Shell user in this case. So actions. I'm going to go ahead and upload a file. At the time of this recording, they don't allow for multiple file uploads, but we only have 3 anyway, so there's no point in zipping it. In this case, looks like I already had this installed, so I'll just go ahead and just clear that real quick. Just so you can see the full upload itself. Okay, now with my items clear, yep, we're good to go. Let's go ahead and try that once more. Upload the file, and you should see a green banner come up here in a moment. And we'll repeat this again under, again, OSSEC lab files. When I upload the DI CI runner XML file as well as the OSSEC conf, this is what we're going to be doing to replace our current one. So we'll try that once more. Sometimes if you're too fast, it'll give you an API throttling limit. Just try it again after giving yourself a couple of seconds. All right, so we're uploading all 3 of these. Too many requests. Okay, well, we'll give that a couple of seconds here. While we do that, just going to do a quick view of that. We're just matching a custom role. This class, again, is not about the creation of payload. Again, regular expressions and strings, and ensuring you have good definitions are a part of that. In general, we're creating something that says, hey, look for echo foobar inside a log payload, and make sure that the previous SID fires, which is one that's built in already, so the anything generically under 100K is considered a built-in with that. So let's try to upload once more, and we're successful. So let's do an ls on there. Now we have the OSSEC conf file and everything else like that. So we'll use to take a look at that real quick. Oopsie. I don't have my coffee today, so apologies about that. So I have right here some commentaries about here and rule ordering. These are generically a stock configuration file, and I just have the inclusive of here to say that we are defining our additional rules inside here. And then last is our test script here, which is OSSEC unit tester. So we're going to do OSSEC unit tester.sh, and this is a local one. This one won't work inside a pipeline necessarily because one, we don't have a build spec file, but I want you to just get accustomed to this. Again, we're only looking for a very specific item. Look for a log entry, the expected rule ID, and we're going to use a built-in binary file inside OSSEC called OSSEC log test, and we're going to redirect essentially everything to our center out so we can actually see what's going on, because in general, this is um, an interactive thing by default here. We're going to make sure we have our log entry piped into standard in there. Um, and then we're going to have a return 0 for pass, and then return 1 for failure. So just a little tidbit on that. Okay, once we have that fully uploaded, we're going to go ahead and do copy from your lab book. We're going to have create a backup just in case. And although we don't really need to, it's just a good practice to do so. So I'm just going to go ahead and copy all these in here. We're creating the backup of all the full, rules that we want to do for, especially with the OSSEC conf in particular. We're copying from the current directory into the rules directory that's made inside var OSSEC rules, and we're using sudo because um, in this case we have to have sudo to actually access the var folder here. I'm also going to do a copy of our existing OSSEC file to overwrite the and replace the OSSEC conf file that was originally for us. And we're just going to do a quick lint on using XML lint to make sure that it's formatted correctly based on what OSSEC needs, just in case, especially those of you with Windows systems like me. We're going to do a OSSEC control restart, and then we're going to do one extra thing here that I'm going to do a chmod plus X alongside OSSEC tester.sh, just so you have that, and for that, you see that turn green based on that. And if you look at the permissions accordingly, you should see X's across everything else. Remember, this is a global executable thing now if I'm using the lazy way and not the octal way. Remember, we're in cloud, so if you're using this inside a production system, strongly consider you to utilize something else in this case. I'm going to go ahead and run this, and notice that I ran it and all tests and checks completed successfully. And what this means is that the foobar payload was seen, and here are the different rules that have been enabled. So here's my log sample that was part of that was part of that file, and here's the sample that came out of an SSH log sudo attempt. It had some decoding phase, and then of course my rule fired based on that a different rule has already fired with it. And this is the output standard out that I got, including errors and things for additional troubleshooting that in general you could see as part of your log. Now let's take a look at a little bit closer what that looks like inside the shell file here. So I want to open this guy up with Visual Studio Code, and I've unfortunately put it into the wrong window. So let me see if I can do a view and making it go easier for you. But in general, you can actually, this is our test pass condition, and exit at 1 if you as a exit break the loop kind of cycle faster. It's not necessary, but I like using it. In addition, I wanted to say, hey, don't fire also that shouldn't work in exit 1. We should be able to do that using bash itself. So now that we know it works using this, we can actually change and comment this guy out, uncomment this guy, and then do a quick trace on the bash shell to kind of assert our theorems about the the logic here. Okay, so let's go ahead and go OSSEC unit tester sh. I'm using Vim. You can use Nano, whatever it may be. I like the colors, so maybe that's just me. I'm going to comment this guy out, uncomment this where I know it's not going to work because it doesn't have echo foobar. Again, we are not testing our detection engineering writing skills. We're testing the fact that we're creating a test to begin with. All right, so I want to do, in this case, the sudo bash um, -x for tracing it out. And let's take a look at how it fares now and what the exit condition is. Now we have an exit condition of 1, and that we have failed the test for sure. So that's what bash is traces for, because it's not matching against the original. We did not see that rule fire based on echo foo bar originally. Again, this would continue as an exit condition inside the CICD pipeline if we refactored it accordingly, and then it would fail the job accordingly for that. Now, those of you that are, perhaps using this in a different system, consider using Chmod 770 for OSSEC unit testing um, as a slightly safer set of permissions. So that's it for this lab. Let's take a look at the next lab in a moment, and we're actually going to do this inside the pipeline. Let's give me 1 second while I get that set up for you. Okay, welcome back. We're now going to start lab 2. Lab 2 is going to be focused in your lab books around task 2 items, which is Suricata logic unit testing. And if you go back to our Suricata unit testing lab files right here, you'll see a repo structure, and you just enter that. And this is what we're going to just generically upload here. Now, I'm going to skip over a couple things just because this isn't rocket science here, but go to your GitHub and log in. Click on New, and then start with the, set yourself as an owner and make it private whenever possible. I would add the README and the license just for fun in there, but you don't have to do it. Make it unique to yourself, such as a last name dash your house number dash something like Suricata unit test. In this case, I made my last name here, and I went ahead and created that for me as a private lab. Now, I've uploaded the same content here. You would do the same thing using add file, upload files, and then what you'll do is you'll drag and drop all of this in here, and this is what it looks like for the remainder of the lab. So as we skip some of these things for the sake of time, I want you to keep in mind that we'll commit these changes. You can, in the real world, you'll write a good description of why you're doing this in general. Okay. So one thing I want you to note is that even though we have a GitHub action flow folder here, that will not be uploaded in your commit by default. We're going to go ahead and do so. So as you go into your actions, you'll have an option in there that says create a new workflow. Um, create a new workflow, call it something. And so what I'll do for the sake of demonstration here once is go ahead and create a new workflow, a new thing so you can actually see what that looks like inside the repo. So I'm going to say child test. We'll delete this shortly after. You can also do this as well. Create it private. Add a README. We'll use the Apache license, sure. Um, create repository. And then you can see for yourself, we can create an upload files right here. We'll drag and drop all of them. And we'll do this for the remainder of the labs as well. And we're going to go ahead and click on commit to the direct branch. Give it some time. Now, if you have DLP or an enterprise solution, VPN, sometimes it might block stuff like this, so keep that in mind. Notice I don't have a GitHub workflows thing here. Click on actions, and you might see this up here, which is set up a workflow yourself. Okay, you'll click that in this case, and then you'll go to, my case, you can either go to the YAML source file here, or I would prefer you to go to this one, just so you know exactly what you're getting into, and you're going to paste that in there. So if you wanted to look through what my runner orchestration file looks like, apologies about that, paste that in there. And then, although you could keep it main.yaml, I like to call it something different. Like in this case, I like to call it Suricata unit test ci.yaml. And then you can actually take a look here. And then as we go through the exercises later on, you'll notice that we'll have modifications in here depending on, especially on the last lab, what your environment looks like. All right, so I'm going to go ahead and close that out and cancel all these changes. I just wanted you to know what that looks like in general. Let's go ahead and delete that repository um, in case you did follow along with me by accident. So I'm going to go ahead and settings, and then you can go in here and actually delete the entire repository right here inside the danger zone. Yes, I want to delete this repository. Yes, I understand that'll blow everything away. Um, I paste that in there. So those of you that are following in this lab, you can go ahead and do the same thing. I'm going to use my passkey in this case. Um, I have a UB key in my case, but your case might be different. Okay, so that's been blown away now. Let's go back to our main lab just for this sake of time here. So once you create the lab and create your action flows in here, I called mine GitHub, Suricata, unit test, runner, YAML, and kept it the same. We don't need to make any changes. Again, if you look for extra folders, you can actually see me testing out some local bash testing by itself, and then I decided ultimately on Python. The rules are the same, zero logon, exploit kit, um, attempts, and then I have a PCAP that has the same thing that I've replicated. Notice our build spec rule is forcibly looking at the rules file, the actual alert name that I would grep out essentially, and the PCAP test. So 0, 1, 2 in our columns here. Okay, so now that you have all this in here, let's go ahead and go to actions. And if it didn't already run, go ahead and click on your action again, and then you should be able to run. Oh, sorry. Click on the side of your action here, and you can rerun your job or run the action in there. As you create your first commit, you can certainly do a workflow right here. Click on all workflows, and you can run jobs, view actions here, and whatnot. So these may change over time depending on when you actually do this lab. But rerun all jobs generically does this for you. Or you can go directly in here, which will take you back to your editing mode. And you can actually download and run the job down here using some of these other menu items. But because of the sake of time here, let's go back to actions. We have our items here, and you can actually click on this down here and run workflow directly, and click on run workflow. That goes back to our event branch for our event triggers, and you might see this turn yellow. And because we already finished this ahead of time, this took about 1 minute and 22 seconds on my end, with a total build time of 1 minute 34 seconds. It essentially isn't anything crazy. It installs Suricata, and in particular runs through um, the deployment process, including my conf file that you have uploaded. So if you go back to our lab folder, right here, it actually pulls Suricata -config in the specifications right here, um, installing Suricata, and it uses the same working home directory, right? So when you're using an action item inside, um, checking stuff out and utilizing the actions checkout, it actually puts you back in the GitHub home directory of your repo. So keep that in mind. So you're using, that's why we use the actions checkout. We use a bash shell, Ubuntu as our production container that is ephemeral. We install Suricata, and then we run our Python test here to run our test. Now, this doesn't specify an argument that you could use in general to make it more modular. For the sake of the lab, to me, it doesn't really make sense to really care about that, but you might be doing this differently. So Suricata rule test ci.py, and we look at that obviously that test passed, right? So we did post cleanup, test pass. It's deleting, cleaning itself off, even though you don't really need to use an ephemeral runner in this case. But if you had a long running runner, like an EC2 instance, for instance, maybe you want to do that. Okay, so it read that, got some signals, all 3 packets processed for the test case. Let's go back to the repo, and let's do a quick look at our Python test script, right? That's the home goodies that we have right now. Again, build script, build spec file, right? I don't specify any path and parameters, but it doesn't really matter. I'm then looking at very specific rules, 1, 0, 1, and 2. And then, of course, I'm just doing a command OS subprocess for executing, giving it some sleep time. You might play with this if you have a slower system. And then, obviously, the pass and fail test conditions, whether or not you found something, the role name, inside the content of the alert file. And I think that's fast alerts right here. And then, of course, I exit accordingly. And of course, I do some cleanup right here if you have a long running runner. So that concludes our unit level test for Suricata. And we're going to get a little bit more complicated in a moment with a synthetic level test. And let's go ahead and set that up. Give me 1 second. Okay, welcome back. I've set up our additional lab here, and I've gone to POE.com. Now, you should have a trial subscription or a subscription for at least a month. Um, and you can go, once you get that subscription activated, go to the API underscore key right here, and then you'll have your key here. Now, I haven't regenerated my key, and I'm going to use this to the lab, so I'm just going to hide that right here using this notepad. But you can go ahead and do the same thing. Make sure you have your key. If you actually accidentally give it out to anyone, go ahead and just regenerate that key and save it in a nice place for yourself. How you make sure you have the access to the API underscore key, it'll show you that if you have a subscription in this case. I use a default bot of Sonnet in this case, but you can use anyone else. I'm going to go to my bots in particular, and I'm going to do you would do the same thing. You would create the bot. And what I want to show you is these settings in particular that are what makes the bot this. Call it whatever you want, internally, we're going to edit this bot. And let's go to our task 2 items here. So we have, so our task 3 items here. So we have our, go back to your lab files, and then eventually hit up the task 3 synthetic unit testing. So we have our repo structure here that we'll create and upload accordingly with a different use case and test cases, and then POE bot files right here. You can upload these files and use these prompts in Markdown. So as you reference these in the lab, you'll see that I have the base file is Claude 3.5 Sonnet, and I'm opening the bot prompt. And this is a Markdown based prompt. And it has some list of guidelines here saying what to do with it. This is the default prompt that gets put with every interaction, regardless of the test you use. And that's why we're using POE.com in this case. So with that in mind, paste that in here, and then upload whatever knowledge bases you want. Remember, we're focused on SPL in general, so you can actually upload different ones. I wouldn't care about Wireshark or anything like that, but this is just an example. The more specific your bot is for unit testing, obviously, the better it is. So try not to upload any more than you need. And notice that I've just kind of done some experimentation here. Delete as you want. There is a limit for that. Cite sources, that way you're kind of forcing it to ensure that it's checking the knowledge base here. Expand advance, you can turn off suggest replies, markdown render, and custom temperature. In general, you want to bring that down to 0.15, okay? So you bring that down accordingly, and then you want to make your bot publicly accessible. So that's something you keep in mind. You need to make sure that is enabled and toggled on for everything that you're doing here. I'm going to disable mine because I'm not um, really using it in this case anymore, but actually we will be for this lab. What am I saying? So let me go ahead and make it publicly accessible one more, and then I have the synthetic test casing in here. Okay, cool. You'll disable this after this lab, so keep that in mind too. So let's go ahead and let's go to our GitHub. You'll create a new repo just like last time, but I want to make sure I am doing my repos, and I want to find my SPL. There we go. I called mine Chow AI Send Unit Testing SPL. And then again, upload your files from the folder uh, repo structure, just like you see here. Now, the main difference is we're going to do a couple things that is a little bit different that other than knowing that you have detection here, SPL, right? Some logs that you, just like any other test case, again, we're using sample information. I want you to notice something here, the same as build spec, but um, in our CI, we have very specific temperatures. I'm calling mine this, but by default, your lab files will say Claude Instant. You will change your edit, right? Edit this file and change it to your public bot name that you used in POE right here. So this is the name of your POE file right here. I'm using this bot here for SPL. Um, and then you can also make sure that you're using um, the base bot, right? Your LLM. So you can actually experiment and change those over time depending on your subscription. All right, once you've made those changes for the sake of this class, and if you really need some help and you just can't get it to work, consider using the default right here, Claude Instant. Notice I use the same thing that we just discussed in our slides right here, low, medium, high, and then we fill anything that's not a high or unknown essentially. All right, cool. Now that we have that, and hopefully you've saved those, and commit changes by clicking that right here. I'm going to leave mine as is. I'm going to cancel my changes. GitHub action workflows. Again, actions, create the new workflow, call it something. You're going to paste the item right here from, let me find the lab file for you. You're going to paste the YAML file that we have. So as soon as you find the YAML file inside here, which is this one, and our main one, again, that's what it looks like. All right. Now, here's something that I want you to be aware of right here as we go into our actions runner here. Click on that to edit your file. And notice that we're going to use our secrets callback. Now, one thing that you need to set up as part of the lab, if you haven't already done so, go to your settings. Actually, go to your settings in here, right? Inside your repo. This is the submenu for that. Go down to secrets and then actions. Create a new repository secret. Make sure you're using the same naming conventions as displayed in the lab. So in this case, capitalizing POE underscore API, and then you're going to go ahead and paste your secret in there that you've saved, and make sure that is saved and enabled and updated before we run this runner. Go to your code here, and then if you want to run your actions manually, you kind of know where to go. So click on this guy right here, one workflow. I'll just show you running one for the sake of this demonstration here. Again, not very exciting, workflow requested. I want to refresh this here. Again, you'll see this here run by. And if it's successful, you'll eventually see it turn green just like this one. And walking through this is how fast it goes, but then you'll be billed every time you click on that run time for the build job. This is going to call back the API to POE. And we notice that with Claude 3.5 instead of the Claude 2, which was part of my original scripting, as the models came out, that it usually just says hi right there. So it still passes because it found a greppable condition essentially. But that's a example of the workflow that's running. And now I'm going to go ahead and just, for the sake of this lab and billing purposes, I'm going to go ahead and turn that public one off, and that way you don't have to worry about anyone using your bot based on a guest name, and assuming they also have the key here. So save, and we're good here. All right, let's move on to the next lab. Give me one moment while I go ahead and set that up. Okay, okay. Let's welcome back. Go ahead and log into your AWS instance, as well as this lab and lab 4. This is our stretch goal here. Make sure you're in US East 1 and that you have administrative rights here in our case. So um, let's go into your lab files, and it's important that you follow all the directions of the lab student guidebook as you see here. AWS IAM policy is what we're going to set up first. So you're going to open these up, and you'll populate this with your AWS account ID here without the brackets here. So you can find that by clicking the copy paste button here. I'm going to have mine ready to go. So if you go to the IAM side, if you have your policies created, you're going to have at least two policies. You're going to have the one for the runner to perform your actual live fire testing here, which has a lot of different stuff you got to put in there. I've narrowed it down to as much as possible. However, if you're still troubleshooting your issues, scroll down to the troubleshooting section of this task here and utilize the much more permissive IAM policy if required. Just note that as a security risk, so keep that in mind. Our second IAM policy that we're going to have right here is the stateful tracking one. We're going to test and utilize Terraform to deploy our thing manually just for testing purposes, but the runner will do this for us as well. Okay, notice that I have all these different permissions here. Please note that over time, AWS changes different things and different things get renamed of the APIs. So again, if you're having trouble, utilize a permissive IAM policy such as an example. I have it in the troubleshooting section of this document. If you're having trouble finding that, look through the last portion of our lab and notice that I will have an allow star statement, and again, I'm given warning for you accordingly here. Okay, so when all said and done, you should have two policies in a brand new account. I call them GitHub, so it's easy to find. If you have an older account, you know exactly what's going to be different. You should have read write for S3 for any objects inside a bucket. And then I'm also going to have two user as my second user policy being the integration thing where I have CloudWatch, EventBridge. These are the same quote unquote services, but they've made EventBridge more robust. CloudWatch is still utilized with some legacy API calls and other whatnot, so they're coupled for now. IAM, we're going to create read and write permissions for sure for IAM user and SNS for as a target to get some alerts and stuff like that for your one and only use case here. We're going to go ahead and create a user. I created a create user, call it mock user, right, in this case, and then provide this manager console access, auto generate it, uncheck this guy next. I already have one, but don't worry about that. And continue on with the lab instruction, and do not create an access key, but do allow them to have one. So I'm going to go ahead and click cancel. Again, this says global right here, but as you return to different services, always make sure you're in US East 1 for the sake of our labs. Okay, after you created the mock user, and actually call it mock user in lower level cases, um, let's go ahead and do CloudTrail logging here. So CloudTrail. Now, CloudTrail by itself is going to have a live buffer, and for the sake of this lab, you still have to create a trail. So again, USE's one, manage events by default, click create trail, and you're good to go on these, right? All right, and that's going to be a different bucket. So if you go to S3, even though it's a regional construct, um, you have to have a particular name here. I have a templates bucket here. Let me make sure that I have my CloudFormation. Yeah, that's just a default one. Since I'm part of an organization, it already has a stack set here for me for SSM. Eventually, when you create yours in a production environment, you'll probably have something similar to that. Now with CloudTrail login enabled, let's go ahead and set up our first S3 bucket um, for the sake of a state file here. You can call it whatever you want. I'm going to call mine, again, USE's one, general purpose bucket. I'm going to call it lab. I'll use my name, lab demo uh, Terraform, right? And I want to make sure I do this and press on leave public access alone, versioning, server-side encryption, so I don't have to use KMS in this case for the sake of lab purposes, but in production you'll use this. Go ahead and create the bucket again. Now I have 3 buckets, but yours might show just this one and this one for now. All right, cool. Now that we have a bucket, this is going to be what our state file is for. We're going to go ahead and move this over here. So um, let me go ahead and do Cloud Shell, and then we'll prepare our Terraform templates to do some checking on this for us. Actually, for our Cloud Shell, let's go ahead and create a repository for our new item here. So I'm going to go ahead and use Xtech demo CI. In this case, you can call it whatever you want. Again, go through the repo structure. So go back upward one. See repo structure right here. Upload those files, including the runner YAML. And then in particular, go to actions, create your YAML file right here. And then you will paste, and you will paste the, it's big enough for you? All right, there we go. You will paste the, go down to the YAML file right here for EventBridge testing, paste it in here. And what we're going to do here is we're going to go ahead and, again, make sure we're in US East 1. And then right here, the role to assume is going to be something we change here. And so keep that window open for now. Again, we're going to be using Terraform to auto deploy, right? In this case, we have a deployment and then live fire testing of our use case as if it were generating a log by itself instead of synthesizing it. And then we're going to validate that is inside our monitoring platform. In this case, we have EventBridge and CloudWatch. Okay, cool. Let's go ahead and um, get our OIDC federation going. So I'm going to go IAM and then make sure that my roles. Yep, I don't have a GitHub role. And so we're going to go ahead and go into the section of your lab book. It's going to have some links. So I'm going to copy and paste this right here for the sake of our time here. Configure AWS credentials by AWS-Actions. This is an official repo by them. They're maintaining the CloudFormation in there. The link I'm giving you, they also have it down here, which is essentially template. Just look for the word template, and bam, it's right here. You're going to download that template and upload this to CloudFormation. So go back to your AWS console, click on CloudFormation. We'll create a new stack set with resources, choose existing template, specify S3 URL, we'll upload the template from the file of the computer, and then we'll go ahead and use this one that we just uploaded, downloaded earlier, validate it, click on next. Once your stack name, we'll say GitHub. Let's see, actions, I like to call it that. Your GitHub org is essentially your GitHub account information, so I'm using DC401 in this case. You can leave all these alone, but the name of our repo is exec-demo, exec-demo CI. Okay, so we'll use this. Next. And then we're going to leave all these alone, including rollback, deletion policies, etc., etc., etc. Next. Yes, right. Ensure that you have the right org and repo name. That's very important for this as we configure our trust information. Acknowledge that we're creating an IAM role in this case. And it should be a few seconds here. So give it a, depending on your region and your internet connection, it might be a couple minutes at most. So we'll keep refreshing. As soon as this click goes into create complete, we should be okay. So I'm going to pause the video right here, and then we'll get back to it momentarily. Okay, now that we've created complete here for our actions, let's go ahead and go to IAM again inside our cloud, our AWS account here. Roles, by default, you have a whole bunch sometimes, so that's why I use GitHub as a name, and I'm going to pull the ARN number here. We're going to push this back into our repo that we created, that you uploaded everything, including and hopefully created the action YAML so far. So go ahead and edit this guy. I'm going to click on the edit this file item here, and then we're going to replace the role right here. Yes, you might know my AWS account ID, but it's not going to be the end of the world. Again, using the same regions, we have the minimal amount of changes going on. I don't see anything else that I need to worry about so far. And then just for safety purposes, we'll go click on main.tf. And so the bucket name and the key is going to be what we change here. So let's go back to our AWS account, go to S3, and then we're going to name it something. We call it ours something different. So we're going to use exec-lab-demo-tf. And then we're going to edit that guy right here in the top here. And again, use same region. You need to edit mine out and use yours. So, but I'm using mine just for the sake of example here. And if I get a bunch of emails from all of you, it's probably because you're actually doing the lab, which is kind of cool. So you can actually change a couple things here. But again, this is our infrastructure as code here that we're going to set up our event patterns and use case for deployment, as well as how we're going to monitor it. Commit changes. Yes. And then our tests, let's make sure we have. Now, if you name something mock user something differently, you need to change that to whatever your new name is. And then we'll make this sure the same thing happens here. Nothing's changed over here. All right, so we're still good on the test itself. In the real world, you might have use cases. So main.tf would be meaning something different, by the way, if you're new to Terraform. Okay, now that we've created our items, we want to make sure that we have a little interesting tip here. Let's go back to the IAM item. And I don't think I specified this in um, the lab book, but trust relations. So this doesn't have to be just for one repo. You can actually make this to an organization alias, and you can have a slash here with repos and prefix names. And so that actually allows you to do multiple repos for one IAM role and runner and stuff like that. So it's actually kind of cool. So we actually federated identity here. So identity provider being defined as a GitHub token here. And then we can actually utilize STS back in our runner for this level of testing. And so if you look at our runner action here, why is it not? Oh, and don't worry about this. We don't have, we didn't add the permission set yet, so don't worry about that. If we go to our runner action here, we'll notice that we are using and applying our role to assume um, in there using the same OIDC packages, which is pretty cool. Otherwise, you have to use IAM keys, and that's just long-lived credentials that you kind of don't need, and it adds more restore organization. Okay, with that in mind, let's go back to our IAM role here. We'll type in GitHub, and so our permissions here, we're going to go ahead and do attach our permissions from that we created earlier. So type in the word GitHub. Hopefully, you name them the same way. I'm going to add these in here for stateful tracking. So that gives it for Terraform deployment capabilities, GitHub Actions for the integration test. So run that, click on apply, and you should have two attached here now. Okay, now that we have that, we can actually run the action flow once more. So let's run the action flow once more. Let's go back to GitHub Actions. Let's run the workflow directly. And now that we attach those permissions, we can see that we're trying to get the job set up. We're configuring our credentials. It's getting the Python dependency code going on there. Now what's cool is we're running the Terraform directly inside the pipeline, which is deploying our infrastructure as code into our account that you see here. And then it validated and passed the test. So what does that mean from our perspective? So it passed the test and ran, oh, no, it didn't pass the test. Xtech lab demo, head object, status code, request, forbidden. And so let's take a look at why that didn't work in our case. So our GitHub runner should have the TF state. Our permissions should have read and write. Yep. And let's make sure that we have our Terraform right here. And our problem is that we didn't, I'll go ahead and end we didn't have a backend somewhere. So it looks like we didn't set up the main TF properly to make sure that we have our Terraform backend. So we have a 403 unable to access the event bridge TF state in S3 bucket because we didn't probably create it earlier. So if you're running into this where you're running the Terraform directly instead of in the pipeline before creating this, we can go ahead and do this inside Cloud Shell. So open up Cloud Shell. And then we're going to go ahead and upload our, let's go ahead and expand that to another window. Again, US East 1. We'll go ahead and make a new directory. Okay. Now that we have a clean directory to kind of work off of, we'll go ahead and make sure that we have main TF. So, and let's make sure we have Terraform installed. And we don't have it installed. So we'll go to HashiCorp. So Terraform, and then it will have inside, just like the manual instructions, we'll have it from um, Amazon Linux right here. So we'll just utilize this guy right here. And in our lab instructions, I'm having you run this manually already, but we've kind of skipped this step over. We'll run this guy to add the official repo in there, and then we'll finally install and run Terraform itself. Okay. All right, we got Terraform in there. Let's go ahead and upload the main TF inside the unit structure here. So our main module. Let's find the repo structure for lab task 4, main TF. Wait for that to go green. Oh, it's in the other folder. So move. I just like keeping things a little bit more organized just for the sake of it. And then we're going to edit that main TF, right? Make sure that you're using the exact bucket that we specified inside our original. And I think it's because I renamed it and didn't run it previously because it can't reference its own. It can't reference a non-existent item here. So unless I have a permission failure, we should be okay here. So let's make sure that we have this. Terraform init. Terraform format. Terraform plan. Let's make sure that this will be successful. Yep. Terraform apply. And then we'll go ahead and press yes. 5 resources added. Let's go back to the S3 bucket. The TF state is finally added. And let's rerun that job one last time. So if ever in doubt, make sure you just touch a file that does this. I did this the longer way because you're going to do this inside the lab anyways, but that's okay. And let's do that test one last time. So it looks like they had a 403 last time. I want to make sure that that's just still the case here. So it says forbidden. It's probably because I don't have the object there in that case. Okay, so we're using the same policies. Again, if you're having an issue based on a potential change, or you skip a step, the more open policy is going to be a little bit easier for you because it has all those permission states for the service. And let's give it another minute. So I'm going to go ahead and pause the video, and let's see how it goes. Okay, so we've come back and it looks like it's still failing. And the reason why is because I think there's been another change, or perhaps I missed this in the policy here. So we have head object here. So we're going to go back and as a troubleshooting step, and I'm glad this kind of happened in this case. So as you go to the lab, you shouldn't have a problem with the lab, especially if you're using the open ones. But we'll go ahead and we'll make sure that we have get object, delete object, put object. And so previously that worked. So we're going to go ahead and use the editor. We'll use the visual editor in this case. It kind of makes it uglier, but um, do it, and we'll see if the permissions line up accordingly. So we have delete object here. Let's make sure that we are still using the same exact same exact Terraform. And so I want to make sure that the one thing I'm concerned about is that we're not using the right bucket. Xtech Lab demos TF. And that should work for you. With that in mind. So that worked locally. So that tells me that we have an integration permission problem with the the IAM role that we're looking at. So again, let's go back and check our IAM role here. We attach both policies in here, and so that tells me there's something wrong with this policy. Perhaps something is missing. So let's go ahead and edit this again. Visual editor. And for the sake of the item, we're going to use all permissions here. And it's probably missing some other things here. These are things that are um, these are kind of newer here for us too. And we'll next and set this as a new version for default. And I'm going to go ahead and pause the video once more, and we'll run the job and make sure that this works. All right, welcome back. So doing there, we're missing a permission set somewhere in there. So as you're going through this lab, looks like another change has happened since between the time of writing and time of use here. Go on IAM. Again, make sure your role has the same GitHub permission needs that we're looking for. So you need to have the Terraform state and then the actions runner right here. In particular, the Terraform state permission policy, I went ahead and edited the using the visual editor. And I went ahead and just added all the S3 actions and then ran the expanded item here, closed it, and then make sure that I had um, everything here passed in there the last time. So again, look through the troubleshooting method. Things can change anytime in here and change frequency. So you can use this policy in lieu of having to use the editor in my case. So what had happened was I was missing an additional permission set for IAM pass role that I perhaps didn't account for. I'll make sure I'll make that change in the lab here. And so when we look at the runner now, the runner successfully checked out the role credentials like we did last time and deployed the dependencies as we needed it. And this time, Terraform initiation on the back end again was able to utilize the SES token given to me. We linted it once more, ran the TF, we validated that the configuration should work. There's no changes because we already deployed um, the resources previously by hand. And then now it ran and generate the access key rule and then validated that access key rule. And what happens is we slept for about 90 seconds to make sure it caught up inside CloudTrail. And so the results happen with at least one query and the test is passed accordingly there. It cleaned itself up internally, but by deleting the key, but it did not remove the deployed rule, which is something that you should consider as part of your production level deployment. So let's take a look here to see what has actually changed in those resources. So we'll go back here knowing that our IAM permissions work soundly. We'll go to S3. Now we see Cloud Shell. We have the demo state file here. We have SNS. And you go to topics. You see that was deployed right here. And then we'll go to Event Bridge. Again, USE's 1. Look at the rules. And we have a default rule that says IAM key access generated. And here's the pattern that we've deployed. The targets are our SNS topic. And if we go to monitoring, we can kind of see here that there was at least one invocation as of recent here. So in the lab, you'll see like a little dot right here in one of these things here. And so this may take some time to catch up. But more importantly, the target is the, if you have a subscriber that's matched the event, the target will show the monitoring fire right here. Now, how do you prove that that actually fired if you don't see it in the GUI? Go to CloudTrail. You can actually see the event inside event history. And then now you see delete access key, create access key that has been done using the federated role. So that concludes our portion of the lab. Again, what you saw me do was I kind of skipped over a couple of things. And so in your lab, follow the step-by-step as I prescribed, which include utilizing Terraform first to kind of get your feet wet. In addition, if you're having trouble with the permissions, as you can kind of see here, there's a couple things you need to troubleshoot here. One, make sure your S3 bucket is the same name in your item. Two, make sure your IAM workflow is referencing the appropriate region as well as the role ARN number. And then lastly, make sure your permissions are set properly. So how you might change that accordingly is IAM policies, go back to your roles, type in the word GitHub, and if you go back to my item here, you can actually create this entire policy item right here. And then you can actually replace that if you wish by creating a new permission attached policy. And you'll create a new policy accordingly, or you'll just edit the same one here, which is edit. And then you can use the JSON to simplify it and just put your account number in here. So remember the red items here are um, something that you have to replace. And so as soon as you replace it with your account number, each time you should have no more warnings there. So we'll do that for the sake of um, making sure that the errors don't show up anymore. And you should see some security suggestions and other issues around that now. Review and save. And if you rerun this thing, your runner again, you should be green just like the other time we did. That is to make sure the surefire way you do it. Again, don't leave this open unless you really have to. And then you clean up accordingly, run the cleanup conditions there. I'm going to pause the video and we'll return back to our lecture and close out. Okay, welcome back. Thank you for sitting through the lectures and the lab demonstrations. Hopefully you found that useful for your unit testing, synthetic testing, and integration testing. And even though we don't focus on deployment detection as code, you did get to deploy a use case in this case in live fire environment and do an integration test asynchronously using using integration testing. So our summary and tips for before we adjourn today is good. What have you accomplished? You created CI/CD pipelines, included the unit testing jobs, synthetic testing, and integration testing jobs, both from a simulation perspective and an emulation perspective using GitHub action flows. You also did the same thing in AWS with the pipelines by deploying your use case. And some further tips for a detection as code program is utilize pre-commit hooks, additional linting, and automate your additional pipelines with maybe perhaps tandem pipelines and make sure you scale everything out. The logical concept that we did was that we pushed things to commit in production and utilize unit testing. And you can actually utilize additional testing in line, so pass or fails, and eventually do a deployment in a logical production environment. I hope you found this lab useful. If you did, let me know. I'm free to happy and more than please connect. Let me know what you thought about this workshop, and I hope to see you again in the future.